scientific research, statistical capability building, and education. So our contribution is based on the article recently published on the Journal of the Royal Statistical Society, where you can find all the methodological issues that today I will skip. I also thank Marius, who cited us before. It took a long time to finish this paper. In 2018, Paola presented a very preliminary version of this paper at the Sports Analytics Workshop, just the idea. But now it is completed and I can present you the main findings. So let's move to the motivation of our work. In the literature of basketball analytics, players' performance is a very important topic. Psychological studies have identified typical performance as just one aspect of the overall performance. Some work refer, for example, to maximal performance, that is what a player can do. Other research, like ours, focused on variability of performance over time. So variability should not be confused with the so-called momentum effect, that is the change in performance related to a previous success or failure, like the hot hand in basketball. The literature states that the hot hand does not exist, even if players believe in it. In this study, we just take note that hot and cold hand can occur and contribute to performance variability over time. So the aim of this contribution is to identify cyclical patterns of shooting performance and to explain how this variability can be explained by the lineup composition. In particular, we start thinking that specific combinations of players on the court can create positive or negative synergies on each player's performance, and then this can affect the overall team performance. The proposed method has been applied to the play-by-play data from the 82 games played by the NBA team Golden State Warriors in the 17-18 regular season. Those data are included in the R package basketball analyzer available on CRAN and presented in our book Basketball Data Analysis with Application in R. More details are on our website bdsports.unibs.it, so if you want, you can have a look there. So we analyzed shooting performance and investigated its relationship with the team performance using a dynamic approach. Data are treated as a time series observed in the event time. So each observation corresponds to an event, for example, one shot. And events occur randomly in time and can be irregularly spaced over time. So we used a three-step procedure. In step one, we define a shooting performance index for each shot of each player. Then for each player in step two, we model the index obtained in step one using a Markov switching model. The aim is to identify different performance regimes. And simultaneously, we investigate the relationships between this player's performance and his teammates and represent this relationship with a network plot. And finally, in step three, we study the effect of the teammates' interactions on the overall team performance. So we move from the pairs of players to the overall team performance. Okay, so in step one, we define a shooting performance index for each shot and each player. To do that, we consider two aspects, the shooting intensity and the shooting efficiency. The shooting intensity is measured by the reciprocal of the time elapsed since the previous shot of the same player. Since this depends on the opponent's strength and also on the pace of the game, we get an adjusted shooting intensity by removing the match effect. So a high value of phi means that shot J of player I has occurred earlier than expected, based on the shooting intensity of that match. On the contrary, a low value of phi, ij, means that the shot j of player I has occurred later than expected, so always based on the shooting intensity of the match. Oh, sorry. Okay. Moving on the second aspect, the shooting efficiency. We defined the efficiency as the difference between an indicator function xij that is equal to 1 if shot j of player I scored a basket and 0 otherwise. And we compute a difference between xij, this indicator variable, and pij, that is the scoring probability of the shot. And here we just take p as the goal percentage of that match, separately for 2-point shots, 3-point shots, and free throws. So, oh, sorry. Okay, I needed this formula. So when Ej is positive, this means that the shot scored a basket because it is positive and has a higher value if the probability is low, so if the shot is difficult to make. When E is negative, the shot missed the basket and has a higher absolute value if the probability is high, so the shot is easy. Then we combine here the shooting intensity and efficiency in a unique index of shooting performance. This is our shooting performance measure by multiplying phi by E. Here we have an example. We have color point showing the shooting performance measure for Kevin Durant. We have the blue point that are the points corresponding to the 2-point shots, the yellow point to the 3-point shots, and the orange point to the free throws. In this way, the intensity can amplify or shrink the shot efficiency. High efficiency results in a better performance if the intensity is high at that moment. Then all these points, all these measures are smoothed by a kernel regression defined over short periods of time in order to avoid the possible noise that can mask the structural relationship. So in this plot, this is represented by the black line. Now, in step 2a, the aim is to see if the fluctuation of the performance index, that is the black line we saw before, are random or represent alternative good and bad periods over time. To do that, we borrowed the Markov switching models from the econometric literature, where they are used, for example, to model economic cycles. Here I skip all the methodological details, but the important thing is that the aim is to detect the significant presence of periods of improving and worsening performance over time. So we have two regimes, good and bad, but good and bad don't mean high or low performance, because a period of high performance that is above the average can involve both improving and worsening. Just a note, to express performance variations, we consider the difference of performance from shot j-1 to shot j with an amplifying factor that is called k, that is estimated from the data following the criterion of maximizing separation between regimes. So it is used to highlight the presence of different regimes. The standard formulation of the Markov switching model has constant transition probabilities, that is the probability of moving from one regime to the other one or staying still in the same regime. Here we used a more complex model where the transition probabilities vary over time, and this dependency is related to the presence on the court of the teammates. So is related to dummy covariates in a logistic regression model that express the presence on the court of given teammates. We selected 11 players who played at least 900 minutes, And the model is then estimated by an EM algorithm, because the regime is unobserved, using R. To avoid instability in the estimates, we ran the estimation 500 times and chose the solution with the highest likelihood value. So we first select the optimal K, then fitted the Markov switching models with time-varying transition probabilities depending on 10 dummy covariates. To deal with the 10 covariates, we implemented a forward stepwise regression based on IC. Results shows that only for 5 players, shooting performance depends on the presence of one or more teammates, and these 5 players were Durant, Green, Looney, McCaw, and Young. For example, Durant shows a significant regime switching dynamic, and the teammates that affect his performance are Klay Thompson and Patrick McCaw, who had a positive influence on Durant's probability of moving from bad regime to good regime. The models are summarized in a network plot where the nodes represent the players and the edges represent the influence of one player to another one. The edge is red when influence is positive and blue when influence is negative. And thickness is proportional to the magnitude of the influence as measured by the estimated coefficients in the logistic regression model. So, for example, this plot here confirms that Klay Thompson and Patrick McCaw have a positive influence on Kevin Durant's regime switching dynamic. Now, in step 3, the aim is to validate our analysis by checking whether a relationship exists between the teammates' interactions identified so far and the overall team performance. So the answer here is not so easy because we are moving the focus from pairs of players to the whole lineup. To measure teammates' interactions in one lineup, we define a score given by the sum of the influences for the players belonging to that lineup. The definition of this score is essentially heuristic. The idea is just to consider all the relationships within one lineup, according to the model, of course, and then the idea is to investigate the relationship between this score and the lineup performance. The lineup performance can be measured by the points made per 48 minutes by that specific lineup. Okay, so now we have the score and we have the points made by 38 minutes by each lineup. And we are now interested in a linear regression of the points made as a function of the score. However, there is a heterogeneity among the points made by the different lineups, of course, due to the different abilities of the players involved in each lineup. So we used a different model than the classical linear one. We used the model-based recursive partitioning algorithm known as MOB and proposed by Zelis and others. With MOB, fitting is not made via a unique global model for the complete dataset, but different models are estimated on subsets of data. And these subsets of data are defined by recursive partitioning. So we have to choose partitioning variables. We used the points made as partitioning variable, and in the regular season, that is our in-sample data, MOB identified one split according to a threshold of 97 points. So this means that MOB detected and estimated two different models, the blue and the red lines here, 4 lineups with points below, the blue one, and above, the red one, 97 points. So the red triangles here represent the lineups with performance above the 97 points, and the blue points represent the lineups below the 97 points. So our models confirm the existence of a significant relationship. So the influences between pairs of players directly affect the lineup performance, so the team performance. The same effect is detected out of sample, so using the playoff data, with very similar parameters. So this shows that this validation can be considered as robust and reliable. Concluding, we modeled the dynamic pattern of basketball players' shooting performance with focus on variability. Results can be represented by means of a network plot that is easy to interpret, and this can be very useful to the coach when deciding which player should or should not play together. The main drawbacks of the proposed procedure is that it needs a rather long time series, because we need enough episodes of regime switching. Another issue is that we consider only shooting performance and not other playing abilities, such as, for example, defensive skills. So in the future, we could apply our approach to a more comprehensive performance index. Here are some essential references. Thank you for your attention.
Okay, I would like to thank Marika a lot for her thorough and well-detailed and well-documented talk. And I would like to ask you if there is any questions for Marika. You can.
I can't see the chat, so
okay,
I'm here. I can take every question or suggestion.
Okay, we have.
Pavlos has a question.
Pavlos. Okay.
Hello, everybody.
Oh, yes, okay. You can switch on your microphone, Pavlos, and.
Yes, you can hear me. Hello.
Okay, everything's fine.
Thank you, Marika, for your great talk. I would like to ask about something that you first mentioned. You showed a graph where you have modeled the shooting performance of Kevin Durant over a number of shots. From this graph, or how do we know if the Markov property actually is existent in our data?
You mean from this plot, isn't it?
Yeah. Okay. Why you would make the assumption that the performance over time is conditioned over the previous times, or it is affected by the previous shots? I mean, these are all different matches, different games.
Yeah, they are all together, but if you see this line, you cannot know anything yet. But then when you build the model, you can make some hypotheses, and then you can find some significant relationship. And if you see not a high number of players resulted to have a significant dynamic performance.
Okay. Thank you.
I think also Ioannis has a question. Yannis, you would like to ask something? Switch on your microphone.
Yes, sorry. Marika, you said something about other measures. I have two questions on that. I guess you can use an overall measure, like one of the well-known in basketball, and do something similar. And my question is, can you use this approach on different performance measures to construct an overall measure? Do you think that this will be useful?
Okay. Yes, this is a good point. It's as I mentioned, it's important to consider all kind of performance, not just shooting performance, but it's also true that we need rather long time series to have enough regime change episodes. So the most important limitation is that we need a huge number of events, so rather long time series to estimate. Your idea to use the model to construct an overall performance measure is very interesting. I need some time to focus on it, but I believe that it could be done, and surely it is a very good suggestion. Paola is here if you want to add something. Paola is one of our co-author. Marco cannot be here today.
No, I have nothing to add to your answer. It's a good idea. We have to think about it, yes. It's not easy to consider all kinds of performances, because with shots it's simple, the shots is made or missed, but when you have to consider defensive skills, for example, it's not easy to define how these skills can be measured. And then there are other issues during the game, for example, related to assists. When a player is on the court, makes more assists to another player because there is a good chemistry between them, and so we could consider that, but it's not easy to measure it. But let it emerge from a model can be a good idea. Thank you.
Thank you, Paola.
Okay. If there is no any other questions, to proceed in the next talk. Okay, thank you, and Marika and Paola, and for this talk, and generally for your work for basketball and data analytics. Okay, now from NBA and Marika, we are transported to Euroleague and Christos Marmarinos. His talk entitled Estimating Team Possessions in Euroleague Basketball Competition. Christos, please share your screen. Okay.
Okay. I will share my screen now.
Everything is fine. You can.
Is it okay? Can you see it?
Not yet. Everything's fine. Okay.
Okay. So, keep presenting. Okay. Do you see the presentation now?
Yes, Christos is fine. Okay. You can start.
So I will try. I cannot be as analytical as Marika before. She's amazing to watch, and it's very difficult to talk after her. I've done it a couple of times. It's not easy. So what we want to do, we started this little research progress with Evangelos Haramis, a student of Mr. Zoufras and Mr. Karlis, and we wanted to get a set of data and try to estimate how we calculate the possessions based with data on Euroleague basketball. Now, let's talk about possessions. I mean, there is a lot of misconceptions regarding the possessions in overall in basketball, and I believe that this is the starting point of analysis. Like, you cannot have a serious analysis without knowing the possessions. And when we define a possession, we talk about
Christo, can you put full screen on your presentation? Sorry for the interruption.
Trying. Okay, I got it now. Okay, we got it?
Yes.
Okay, so when we talk about this type of an event, it starts when a team gains control of the ball, and it ends when the opponents take it back. And there's a lot of, as we said, a lot of misconceptions with these things. Basically, basketball is just a game with alternating possessions. Now, since the possessions alternate, how do they alternate? How do they end? How do these possessions end? It can be with a turnover, which is a steal. It can be offensive rebound, tackle violation, the ball goes out of bounds. It can be with a defensive rebound after a missed shot or a missed free throw, and after a score. Score can be a 2-point shot, a 3-point shot, and the last made free throw. And I'm highlighting this because this will be something that we will find in the future. This is the only thing that makes it a little bit difficult for us to calculate the exact numbers of the exact possessions count if we don't have the actual number. We calculate with this basic metrics, and all basketball analysis ends to 1 point, and this is the rim, this is the basket. So whatever is said and done before, when we talk about analysis of offense, if it goes in, it goes in. And this is everything ends in anything offensive in the scoring. And the offensive rating, which is basically the number of points scored in 100 possession, and the defensive rating, which is the numbers of score received in 100 possession, is the starting point of any analysis that we want to make. Again, possessions is the key. Now, how do we track possessions? Let's say we want to measure them. Lately in the NBA, and this is the answer of a lot of things that Paula mentioned before, as far as defense. This is the automated systems that camera systems that exist in the arenas of the NBA, which is basically, what is it? It is a set of cameras that dissect the basketball court, and it automatically detects where the people are, where the 10 players are on the court, and how they're moving, with what speed, with what distance with each other, with it counts anything that interacts in their motion, basically. And this is a very, very easy way to get the possessions if you are an NBA team or if you're a high-level college team, because so far in Europe we don't have such systems installed in the arenas. The other thing that we might do is watch the video analysis. Video analysis, Synergy, Instat, whatever else video analysis companies out there, or is it by just watching the game? We can count how many times a team has the ball in order to attack, how many times the opponent has it. We'll find it that it's within 1 or 2 possessions. This alternation goes on. The third thing, so for the second thing, okay, we cannot be an NBA team, but we have to be a team that will play in a significant league, a team that will play somewhere where there is television coverage or there is film or whatever. The third thing that we can do is we can go to the play-by-play data. Again, it's easy to find. We have to make sure when the possession alternates, and there is a bunch of ways that we can do it with R, with even with Excel. But the disadvantage again here is that we need to be in a team with a league that is recording the play-by-play data. And okay, Euroleague, they do it. Some top leagues, they do it. But the vast majority of the people that will be in sports will not start by being in Euroleague, will not start by being in the NBA, will not start having automated camera systems in their arena. They will start with small gyms. They will start with working with kids, juniors, and there they will have box score. And even if nobody keeps the box score, they can keep themselves. They can have a kid, they can have a parent, they can have someone on the bench keeping the box score statistics. And out of these box score statistics, we can start being analytical in the way that we think about basketball. And this is, for me, extremely important because we're talking about the high-end analysis in the highest level, but these people need to start from somewhere. And these people that are involved in basketball need to start by very, very small things. That is having a game in the neighborhood, having a game in the local league, keep the box score, see what kind of analysis we can make after that. learn to think analytical. Now, what did we want to do? What do we want to do? We want to estimate the possessions out of the box score. Simple as that. We want to make the knowledge available to all levels. As we discussed, we want it from the NBA until the last person playing basketball, organized basketball anywhere in the world. And how do we want to do it? We want to do it by using data from European basketball played in Europe. It's all research done as far as possessions and as far as calculating all these things have taken into account NBA statistics. Well, basketball might be similar, but it's not really the same. So we had an idea of going back and trying to discover some sets of data that's been from Europe and see what we can do with it. What kind of data did we use? We use play-by-play data from Euroleague. The last 3 years of the competition, we watched a total of 772 games. That's a courtesy from New Stats EU. Why did we select to use this data? Because we will see, as we'll see later on, Euroleague is changing the format every couple of years, and this is a period of time that they kept the format the same, although the 1920 season was never finished. It's still, at least the format stayed the same, the teams remained the same. This is why we choose this last data. Again, why? Because there has been problems with the data quality in the previous seasons. Any of you that have spent time manipulating data from Euroleague, even from the official play-by-play made from Euroleague basketball, we'll see that there's a lot of problems, there's a lot of bugs, there's a lot of missed possessions, there's a lot of things that we need to go back to the video and see how to manage it manually. It wasn't easy. There's been a lot of mistakes. This is a major problem in the European basketball, the sets of data that we have. And as we said before, the constant change of the format creates some problems. That's why we want to keep it simple. Now, how do we do it? How do we do it? We have some sample formatted game, which the sample was formatted game by game, and we used the multiple linear regression analysis in order to continue with our estimation of the possessions. Now, I'm trying to keep it as simple as possible. We reached to four different formulas in order to to calculate the possessions. I'm going to use the simple one, the most simple one that we have, which is 0.977 field goals attempted minus offensive rebound plus the turnovers plus the free throws times 0.454. Now, what do they say? I mean, forget about the title, forget about this, coefficients and all these things. What do these things say? And it's the logic. It says that every turnover terminates a possession. We knew that. The data verified it, and simple as that. Turnover terminated the possession. There's been very few exceptions. This 0.977 and this is 0.954. There's been some very few exceptions for the field goals attempt and the offensive rebound that terminate a possession. And we'll talk about it later on. We want to keep your interest, keep you waiting for something. So that's why we're not going to say it now. We're going to say it in a few more slides. So keep that in mind. There's an asterisk in your head. And the free throws, there's a major talk. We said it before. We're anticipating. There's a major talk about free throws. How many free throws? Which are the free throws that terminate the possessions? Because as we said, the free throw in basketball can be 1, can be 2, can be 3. It's not the typical. The simplified version. We like to keep things simple. So we take away this 0.977 and so on, and we say that the possessions is a formula that consists of the field goals that were attempted, the shots, minus the offensive rebounds plus the turnovers and the free throws with this coefficient. The correlations with the actual possessions that were measured by the play-by-play was 0.98. So basically, it's the same thing. We can use it. We can use this formula. It's very, very highly, extremely highly correlated with the actual possessions that were calculated from the play-by-play set. The weighted version, the previous one, underestimates a little bit the possessions, the actual possessions. The unweighted, this one, the simplified one, overestimates it. But overall, both of them, they're so close with the actual possessions that we can keep it. Because, as we said, we want to talk to the average starting coach that wants to make entry level in the analysis. That's why we want to keep it as simple as possible. Now, let's look at this little table of offensive rating. The left part of the table is the offensive rating that was calculated by the actual play-by-play data. And the right side is the one that was estimated by the formula that we had. And if we see, almost all the teams, maybe except Zalgiris, which is right in the border of having this offensive rating, and actually the parallel line, this one is the estimated offensive, and this is the defensive. So we have both of them, and we can see that it's pretty much the same. Nothing really changes dramatically between the true and the estimated one. So we kind of thought about it, since there's a 0.98 correlation, and it's kind of safe to use it because nothing really changing when we're mapping the teams as far as offensive rating and defensive rating, which is, as we said, the building blocks of the analysis, of the entry-level analysis for basketball. Now, let's talk a little bit about some practical applications. The first one who talked about this per possession analysis, and he really went into analyzing this, was Dylan Oliver with his 4 factors back in 2004. What are those 4 factors? Everybody's heard about it. It's about basically how one team can maintain, how one team can work with their possessions. First of all is you got to make your shots. You want to score, you got to make your shots. Simple as that. What metric did he use? He used effective field goal percentage, which is, as we all know, a field goal percentage that accounts for the fact that the 3-point shots is more than 2-point shot by 50%. So we take that into account. Then the second thing that he talked about, and he said about we got to get control back of the game, of the ball. It means go to the offensive rebound. And we cover the offensive rebound percentage, which is what's the percentage of the balls that were missed that the team got back on the offense. We got to secure the ball, which is in the form of the turnover percentage, and we got to go to the line because that's another way to score. So he created those 4 factors and related them to the result. The second step that he did was assigning weights to them. And we see on the left side of this thing, of the table, we see that the weights that we received was 40% for effective field goal in NBA, 20% offensive rebound, 25% turnovers, 15% free throw rate. Well, we put these numbers to a test for Euroleague data set, and we saw that effective field goal had a little slighter importance in Euroleague, 42, offensive rebound a little bit more, a little bit less, turnover a little bit more, and the free throw rate was not really so hot in our data, in this Euroleague data set. It was only accounted only for 8% in the weights. Now the R square. Let's talk about win projection, because in the end we want to use the analysis because we're looking for the win, and we want to see how these things related. Now the R square is 0.9 to 8. Free throw rate, low importance in EuroLeague standard, not statistically significant in the P was higher than 0.05. And the increase of 1 unit in 4 factors or decrease in turnovers, we understand it's all the same, will increase the chance of winning percentage by 8%. The AIC criterion was minus 37.37. And what we did next, we said we try to get a better result as far as relating some factors of this possession management to the winning percentage. We applied backward stepwise regression, and we found a little bit better formula with less total predictors and slightly better R-square with 0.931. What was it? 3 pillars. That's how we called it. We took away the free throw rate and kind of merged it with the effective field goal percentage, and this basically this metric is basically true scoring percentage, which had a 47% contribution to the actual formula. We kept turnovers, we kept offensive rebounds, we gave a different weight, and now any point of increase in any of these 3 pillars will increase 7.7% the win percentage of a team, and the AIC criterion is minus 40.11. And this is Fenerbahce 3 pillars example, and we see the opponents here. We see the opponent true scoring percentage and their own true scoring percentage, and we see where they lie. Fenerbahce this period, it was 18-19, was the best, had the best record in EuroLeague. So our findings were close to what the actual winning record was. And let's go to the asterisk. There's some very few exceptions for why field goal attempts and offensive rebound is not 1, and it was something was missing, 0.977 and all these things. There's some shots at the buzzer, rebounds at the end of the quarter that are not really accounted for in changing of possession. So that's the one thing that kept it from being 1. We actually turned it into 1, as we said, without a big problem. And this 0.454 coefficient, what does it show? Those are 45.4% of the free throws that are shot in the game are the ones that changed, that terminated the possession. So when we're talking about how many free throws terminate the possession, in Europe, it's 45.4. What NBA uses, it uses 0.44. And this is something that was done from similar analysis from Kubatko and all back in 2007. They used a set of NBA data from 10 seasons in a row, and they found that 44% of the free throws were terminating a possession. Us in Europe, it's slightly bigger. It changes a little bit the possession count, and this is what we want to use from now on when we talk about Europe estimating possessions in European games. Why is it important? Why do we want to do it? First of all, as we said, we're using data from Europe, from basketball played in Europe. That's one. The second thing, we want to keep it simple. We want to keep it as simple as we can in order to estimate this equation. And why? Because we want to make available to everybody to start thinking about analysis per possessions. We need to have them think that I need to have the possessions of the game because I want to make the offensive rating. I want to make the defensive rating. I want to make something that is beyond, okay, they scored 90 points, they have good offense, and all these things. We want to help people think analytical, and this is the first actual steps. And that would be all from me today. Thank you very much. As we said, keep it simple and have people think about analytics.
Thank you, Christos, for your very, very interesting talk. And we have questions from Mr. Michalis Tsagris. If you want, Mr. Tsagris, switch on your microphone. And
yes. I would like to ask Mr. Marmarinos.
Yes.
You were using the observed data, the true, let's say, possessions. You were estimating the possessions, and then you were computing the R squared. Did you try any cross-validation?
We correlated the results, and it was a high correlation. That was what we did.
Okay.
Next question from Mr. Konstantinos Pellegrinis. Hello, Kostas. Hi.
Hi. Very nice presentation. I had one question on the 4 factors. Did you try to do also actually a multiple regression for 8 factors, the offensive and the defensive, and basically see whether, indeed defenses win games or it's a myth?
No, we assume that these factors work the same on defense and offense.
Okay.
So the same 4 factors that exist on offense, the same 4 factors exist on defense. So that's why we didn't do it. So this thing that we said using the true score percentage is also an effect for defensive. It just didn't happen.
Okay. Okay.
I don't know which one is more significant, but this is something that we need to try to find out which weights more offense or defense. And I think it would depend on the league. It's not going to be something unilateral for everything, but it's a good start to have another research like this.
Okay, thank you, Christos. The next question is from Professor Karlis.
Okay. Hi to all. Thank you, Christos, for this talk. Just a quick question. You base your result on Euroleague. So I wonder, how much do you think that this generalizes to the local, let's say, to the championships within Europe, and also to some more championships like youth championships, as you said, because you said that this would be very, very important in order to develop things. So actually, if I ask you, what do you think that we should amend in order to make this generalizable? I mean, for example, for the Greek championship, for a for the league, what do you think that we should alter? I know that there are no data to fit something like that, but actually you think that it is just the free throws, or we must make a lot of amendments?
No, I think the only thing that can really influence it is the free throws. And we use Euroleague because it has representation from many countries, from many teams with different countries. And these teams can also play in the local leagues. And usually what we see, it doesn't really change that much the game between, let's say, a Euroleague team and the Spanish league team, which they have anyway 4 teams there, or VDB, which they have already 3 teams in Euroleague. And this is why we thought about making this generalization. It's closer because it's like Euroleague is a representation of smaller leagues into the system, and we don't see a lot of differences in the way that the teams play between Friday and Sunday, between a Euroleague game.
So if you split the data, let's say, to the games played by Spanish teams and the games played by, let's say, Russian teams or whatever, do you think that this may create a difference? Or, I mean, it is very homogeneous and there is nothing to do with that?
We haven't done it. We haven't done it. The thing that is really hot right now, and now, okay, I will go make this question for you, because it's something that we're looking for in the NBA, is a way to rate the leagues. Yeah. This would be something very interesting to do. Now, this metric of possessions will show only the tempo that is played in EuroLeague, and I would suspect that it wouldn't be that different from what they play in other leagues. But the quality of the league and how we express it, this is a very, very hot topic in the NBA right now as well. A lot of teams are trying to do this because they try to put a grade in when they try to select people from the draft to see how competitive the league is and all these things. And they still haven't found a way to do it.
If we move to youth leagues, do you think that let's say the coefficient for free throws will decrease or increase?
If we were to?
If we move to youth leagues, or let's say to non-professional leagues,
it will depend on the officiating, because the officiating there is not really very consistent.
Okay.
Usually, big leagues, they have consistent officiating because every official is under the control of their group, their organization. So I think it's more, the criteria are more set. I think youth leagues they can vary because they're being officiated by usually young referees, and they are in the learning process there.
Okay. Thank you.
Okay, the next question is from Paula Zapulotto. Paula.
Hi, thank you for your presentation. About the weight of the 4 factors on the winning probability, there is a question I have often asked to myself. Do you think that the weight can be systematically different according to some specific circumstances related to the game? For example, during difficult games or during easy games, balanced or unbalanced with respect of the 2 teams. Can this impact on the importance of the 4 factors for the winning probability?
I would suspect from the basketball standpoint, not from a statistical standpoint, I would suspect that there would be a difference. There also would be a difference between playoffs and regular season. And I think it would be a difference between teams that have similar winning record and teams that are far away. I would suspect, for example, that teams that have their winning records are not similar. One is like 80%, that one is 40%, that the offense play more important role, whereas in some more similar things, some small teams, similar teams, maybe I would suspect difference to be a little bit more involved like this. But yeah, this is a great way to see it. Try to differentiate according to to other events and not to unify all of them together.
Okay, Marek and I are trying to model just this, and we are using the MOB models that she mentioned during her talk. And I'd like to know your opinion about that, because we have to choose the partitioning variable, and so this can be very useful. Thank you.
Okay.
Christos, there is another one question from you from the chat. I'm reading this from Vasilios Pyriochos. Are the problematic data provided from Euroleague create any problems to your research?
Yes, we found actually a huge bug there, and we had to redo it again, and we have to let the Euroleague know that they had a big huge bug in the data. It's when we go to data analysis and you take any type of data from Europe, you have to be very sure that you take care of the last detail, because I wouldn't trust anyone with it. And hopefully there in NewStats, they did a good job with working with this data. And also Evangelos Haramis, who was the person responsible for making the research, also was very good in finding these problems that we had.
Okay, thank you very much and for your talk and for your responses to all these questions. Professor Zoufras, I think the last word is for you, just to finish.
Okay, let's thank again Christos Marmarinos and all the speakers for the wonderful contributions today. I think all the talks were very good and high level. I hope the whole session was not very tiring for you. So we are going to have our next meeting for the second day tomorrow at 5 o'clock with more engaging topics and talks on about sports analytics. So see you all here in the virtual room of Teams for the second day tomorrow at 5 o'clock. Thank you very much for attending our event.
Thank you very much, all the speakers and all the participants.
Have a good night.
Good night.
Thank you. Bye-bye.
Good night, everybody.
Bye. See you tomorrow.